In the last few episodes, we covered how to control an Arduino using HTTP, Blink, and the Cayenne app. However, as I told you in the last episode, I am a big fan of voice command, and I use Siri on a daily basis. This is why today we are going to see how to control an Arduino using Apple HomeKit, which also allows us to use Siri voice commands. If you missed those last episodes, I will leave their link in the description below, and I strongly recommend that you watch them, especially the episode about HTTP, because it will help you better understand what happens behind the scenes when you control your Arduino over Wi-Fi. The most commonly used method to control an Arduino from the Apple Home app is by using Homebridge. Homebridge is an open source software that will create a server to bridge your Apple products with your smart devices. You can download Homebridge on Windows, Mac, Linux, and Docker devices, and most importantly on Raspberry Pis. This is great because you can buy the new Raspberry Pi 4 starting at $35 only. However, for this project, I will be using the Raspberry Pi 3. Apple HomeKit uses the HomeKit Accessory Protocol, or HAP for short. And Homebridge's job is to translate and manipulate those commands to more common protocols such as HTTP or MQTT. And to do so, it needs custom plugins for every new device or feature. There are plenty of plugins already available, and they are all completely free. You can also create your own plugins if you need to by using the Homebridge API. Similarly to the previous projects, we will try to control a LED and read the temperature and humidity using the HomeKit app. To do so, start by downloading the official Raspberry Pi image and the Balena etcher from the official homebridge.io website. I will leave all these links in the description below, in addition to links for the Arduino sketch and the Homebridge configuration file that you will be using later. While the image is downloading, upload the Arduino Homebridge sketch to your Node MCU. You will need to modify the Wi-Fi credentials by entering your SSID, which is the name of your Wi-Fi, and its password. After uploading the sketch, open the serial monitor, and it should print the IP address of your Arduino. You will have to note it down because you will need it shortly. Now back to the Homebridge image. After it finishes downloading, use the Balena etcher to flash the Homebridge image to your Raspberry Pi SD card. Once that is done, insert your SD card into your Raspberry Pi and power it on. Wait for 2 to 3 minutes and scan your Wi-Fi network. You should now see the Homebridge Wi-Fi setup appear. Connect to it and you will see a portal pop up where you can select your Wi-Fi SSID and password. Once that is done, the Raspberry Pi will reboot and connect to your Wi-Fi network. Now we need to find the IP address of the Raspberry Pi. So from your browser, go to your router's IP address. If you don't know it, you should probably find it on the back of your router. After logging in using your username and password, which are also available on the back of your router, search for something called DHCP client list. There you can see all the devices connected to your router. Locate the Raspberry Pi and write down its IP address. We will also need to locate the Arduino and note down its MAC address. We need the MAC address of the Arduino to reserve its IP address because IP addresses change frequently, and we can do so in the DHCP address reservation section, where you will need to enter the MAC and IP address of the Arduino. Once that is done, we can start configuring our Homebridge server. To do so, if you are using Windows, go to the Raspberry Pi's IP address. If you are using a Mac or a mobile phone, you can simply go to homebridge.local. The default username and password are both admin. Now that you are inside of our server, we need to install the needed plugins for our project. Go to the plugins menu on the top of the screen and search for Homebridge-HTTP. Now locate and install the Homebridge HTTP plugin from Rudders. This plugin will allow us to customize two URLs, one to turn the LED on and the other to turn it off. You can see in the Arduino sketch how we are controlling the LED and replying to the server when we receive those HTTP requests. Next, we need to install the Homebridge Advanced HTTP Temperature Humidity plugin from Ingo Walther. This plugin will allow us to customize a URL to request the temperature and humidity from the Arduino. In the Arduino sketch, we can see how the temperature and humidity readings are sent back to Homebridge in the form of a JSON file using HTTP. Now, to modify the custom URLs of the two plugins, we need to go to the config menu of the Homebridge server. Then, copy and paste the configuration file that I will link in the description below. And make sure to modify the three URLs so that they match with the IP address of your Arduino. After that, save the config file and press on the power button on the top right of the screen. This will restart the Homebridge server and apply the new changes. Finally, we can open the Home app on an Apple device and add a new accessory. Use your camera to scan the QR code of the Homebridge server. Make sure your Apple device is connected to the same Wi-Fi as the Homebridge server and the Arduino. Once you finish configuring the device, you should be able to control the LED and see the temperature and humidity in the Home app. And you can even ask Siri, "Turn the LED on."
Okay, the LED light is on.
"Turn the LED off."
Okay, the LED light is off.
"What is the temperature in the room?"
It's 25 degrees Celsius.
"What is the humidity in the room?"
Humidity in the bedroom is high, at 67%.
As always, if you are encountering any problem, share it with me in the comment section below. You might also be helping out someone with the same problem. The main advantage of using Homebridge is that it also allows you to connect other smart devices that are not HomeKit compatible, such as the Nest and Ring products. However, we've seen how complicated it is to set up the Homebridge, especially because we need a different plugin for every new feature, and because we need to modify the Arduino Sketch to be compatible with all the plugins simultaneously. This is why next week I'll show you how to completely ditch the Homebridge server and let the Arduino be a server on its own that will directly communicate with the Apple devices using the Apple HAP protocol. So if you don't want to miss this episode, make sure to subscribe. In the meantime, you should probably watch one of the videos on the screen right now and leave a like if you found this video useful. And I can't wait to see you in the next episode.